Hello students, today we can start exercise 10.2. Before starting this exercise, what is studied before? 2-3 points only we should recap. In theorem 10.1, this is the center of the circle, theorem 10.1. AB is the tangent to the circle at the point of contact P, and O is the center of the circle. What we got? OP is perpendicular to AB, means this angle is 90 degree we got. And in theorem 10.2, suppose P, this is the point of contact A, this is the point of contact B, this is the center of the circle O. What we got in theorem 10.2? PA is a tangent to the circle at the point of contact A. PB is the tangent to the circle at the point of contact B. We got OAP, triangle OAP is congruent to triangle OBP. After congruency, we got this side or this tangent AP equals to BP. By CPCT, also by CPCT, we got this angle. Suppose this is angle 1 and this is angle 2. We got angle 1 equals to angle 2. That means OP is the angle bisector of APB. So theorem 10.1 we got radius is perpendicular to the tangent at the point of contact P. Theorem 10.2 we got this triangle OAP is congruent to this triangle OBP. These are the right angles obviously. Because according to theorem 10.1, this will be 90 degree, this will be 90 degree. After congruency, we got length of this tangent AP is equal to the length of this tangent BP. Also, we got angle 1 is equal to angle 2. That means OP is the angle bisector of angle APB. Also, one more thing. Suppose this is the center of the circle and this is the chord of this circle AB. If we draw perpendicular from the center to this chord, that means if it is 90 degree, if OP suppose OP is perpendicular to AB, then AP will be equal to BP. That means perpendicular from the center bisects the chord. Next we are starting question number 1. From a point Q, the length of the tangent to a circle is 24 centimeter, and the distance of Q from the center is 25 centimeter. Find the radius. This is the tangent. This is point Q, and it is given length of the tangent to a circle is 24 centimeter. Suppose this is point P. This PQ length is given 24 centimeter. Suppose this is the center of the circle O. The distance of Q from the center, this is the center of the circle O. From point Q, the distance of the point O is 25 centimeter. It is also given 25 centimeter. According to theorem 10.1, this will be 90 degree, means triangle OPQ will be a right triangle. We have to find radius of this circle. That means radius OP is how much, that you have to find. In a right triangle, OPQ, we can use Pythagoras theorem. OP square plus PQ square, OP square plus PQ square is equal to OQ square. It is suppose perpendicular, it is base, it is hypotenuse. OQ square. OP we do not know. So OP can be written as OQ square minus PQ square. OQ is given how much? 25 centimeter. PQ is given how much? 24 centimeter. So we can write in place of OQ this 25 square minus 24 square. A square minus B square. We can write A plus B into A minus B. 5 plus 4, 9, 2 plus 2, 4, into it will be 1. That means 49 is 7 into 7, it will be 7 centimeter. So OP we got 7 centimeter. Option A is correct. Correct. This is the length of the tangent PQ. It was given 24 centimeter, and distance of point Q from the center O, it was given 25 centimeter. Our requirement, we have to find the length of the radius OP. OP we got 7 centimeter. Option A is correct. Now question number 2. Question number 2, diagram is given already. Two tangents. This is the center. OQ, T, it is given P. TP and TQ are the tangents. Here TP and TQ. TP and TQ are the tangents. This is the given data. POQ, this angle is given 110 degree. POQ equals to 110 degree. We have to find PTQ. This angle we have to find. Angle PTQ equals to how much? OP is the radius, PT is the tangent at the point of contact P. OP is the radius and TP is the tangent at the point of contact P. So according to theorem 10.1, OP is perpendicular to TP. That means OPT, this angle will be 90 degree. OPT equals to 90 degree. Similarly, OQ is the radius, TQ is the tangent at the point of contact Q. Then OQT is also 90 degree. We can write similarly. That means for the similar reason, we can write again TQ is the tangent at the point Q, OQ is the radius of this circle. So OQ is perpendicular to TQ and OQT is 90 degree. Here we are writing similarly. We got OPT, we got OPT 90 degree. Similarly, OQT equals to 90 degree. We have to find the measure of angle T. This angle is also given. In quadrilateral, OPTQ is a quadrilateral. In quadrilateral, OPTQ, we can write angle O plus angle P plus angle T plus angle Q equals to 360 degree. Angle sum property of a quadrilateral. Angle sum property. Angle O, it is 110 degree. Angle P 90 degree. Angle T, it is unknown. Angle Q 90 degree equals to 360 degree. Now 110 degree plus 90 degree means 200 degree plus 90 degree means 290 degree. We can write T equals to 360 degree. This plus this means 200 plus 90. 290 coming from left side to right side. Then angle T will become 360 degree. It is 290 degree. 6, it is 16 minus 9 is 7. 3 will become 2. 2 minus 2, 0. We got 70 degree. That means, what was the question? PTQ how much? PTQ. We got how much? 70 degree. Option B, it is given 70 degree. Therefore, option B is correct. Is correct. Now question number 3. If tangents PA and PB from a point P to a circle with center O are inclined to each other at an angle of 80 degrees. Two tangents are there. PA and PB. This is the point A, P, A point, B point. PA and PB are the tangents to the circle at the point of contact A and B respectively. Center of the circle, it is given O. PA and PB are inclined at 80 degree. It is also given, that is, this is PA, this is PB. They are inclined at an angle of 80 degree. This is given 80 degree. That is angle APB, or you can write angle P equals to 80 degree. We have to get POA, angle POA, angle POA. That means we have to join it. Angle POA, this much we have to get. Angle POA equals to how much? We know OP is the angle bisector of angle P. OP is the angle bisector of the angle P. This we got from theorem 10.2. After proving the congruency of these two triangles, we got PA equals to PB and by CPCT rule, and also we got APO angle equals to BPO. That means OP is the angle bisector of this angle P. That means this angle and this angle, they are equal. OP is the angle bisector of angle P. Suppose this angle is angle 1, this angle is angle 2. That is angle 1 is equal to angle 2. Now what is the total of angle 1 and angle 2? That is given 80 degree. So angle 1 will be half of 80 degree and angle 2 also will be half of 80 degree. Equals to 80 degree upon 2 equals to 40 degree. So we got angle 1 is 40 degree. OA is the radius and AP is the tangent. OA is the radius and PA is the tangent at the point of contact A. So, according to theorem 10.1, OA will be perpendicular to PA. That is, suppose this angle is angle 3. Angle 3 will be 90 degree. In triangle OAP, we got this angle, angle 1, this angle, angle 3. We have to calculate this angle. Suppose this angle is angle 4. In triangle OAP, angle 1 plus angle 3 plus angle 4 equals to 180 degree. Angle sum property. Put the values. Angle 1 we got 40 degree. Angle 3 we got 90 degree. Angle 4 we have to calculate. 90 degree plus 40 degree. It is 130 degree. Angle 4 180 degree minus 130 degree. 80 minus 30 is 50. 50 degree. Then which option is correct? Option A, it is given 50 degree. Therefore, option A is correct. Question number 4. Prove that the tangents drawn at the ends of a diameter to a circle are parallel. This is a circle. Suppose center is O. Suppose this is a tangent. Diameter, suppose it is AB. Suppose tangents are PQ and RS. Prove that the tangents drawn at the ends of a diameter of a circle are parallel. So given data, given a circle with the center O, and AB is the circle, its center is O and AB is the diameter. PQ and RS are the tangents to the circle at PQ is a tangent to the circle at the point of contact A, and RS is a tangent to the circle at the point of contact B. You have written here PQ and RS are the tangents to the circle at A and B respectively. Respectively means PQ is the tangent at point A and RS is the tangent at point B. Points A and B are the ends of the diameter. Points A and B are the ends of the diameter AB. At these ends, PQ is the tangent and RS is the tangent. We have to prove what? To prove PQ is parallel to RS. These tangents are parallel. PQ is parallel to RS. This we have to prove. So here given data are written. I have to clean this part. Prove. OA is the radius, PQ is the tangent. So OA will be perpendicular to PQ according to theorem 10.1. OA is the radius and PQ is the tangent. Therefore, OA is perpendicular to PQ. Suppose this angle is angle 1 and this angle is angle 2. If OA is perpendicular to PQ, then angle 1 will be 90 degree. That is, angle 1 is 90 degree. Next, similar reason, OB is the radius, RS is the tangent. So OB will be perpendicular to RS. We can write similarly. OB is perpendicular to RS, that is, this angle 2 will be 90 degree. Say PQ is a line, RS is a line, and AB, it intersects PQ and RS at point A and B. So it is a transversal. Now angle 1 and angle 2, they are lying on the same side of the transversal. First, angle 1 and angle 2. Angle 1 plus angle 2 equals to 90 degree plus 90 degree equals to 180 degree. Now give the description. Angle 1 and angle 2 are the co-interior angles on the same side of the transversal, or interior angles on the same side of the transversal. Simply you can write co-interior angles. Angle 1 and angle 2 are the interior angles, or we can write the language, angle 1 and angle 2 are the interior angles on the same side of the transversal. Angle 1 and angle 2 are the co-interior angles, and the sum of angle 1 and angle 2 is 180 degree. Means angle 1 and angle 2 are supplementary angles. If angle 1 plus angle 2 is 180 degree, then PQ will be parallel to RS. The reason is given here. Angle 1 and angle 2 are the co-interior angles, and the sum of these two angles is 180 degree. Hence, we can write PQ is parallel to RS. Proved. By anyway, if we can prove that angle 1 and angle 2 total is 180 degree, and they are lying on the same side of the transversal, then these two lines should be parallel to each other. Question number 5. Prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. Suppose this is the center of the circle. What is given? Prove that the perpendicular at the point of contact to the tangent. Give the name of this tangent A, B. Given a circle with center O. AB is the tangent. AB is the tangent to the circle at the point of contact. Suppose it is ABC at the point C. Now, one more thing is given. The perpendicular at the point of contact to the tangent to a circle passes through the center. This is the perpendicular to the tangent. PC to the point of contact, one perpendicular we got. PC is perpendicular to AB at the point C. Then suppose this is angle 1, that is angle 1 is 90 degree. What we have to prove? To prove the perpendicular at the point of contact to the tangent, the perpendicular at the point of contact to the tangent passes through the center. To prove PC passes through the center. PC passes through the center. What is the center here? O. You have to prove this. I have to clean this part. Theorem 10.1, OC is the radius and AB is the tangent at the point of contact C. OC is the radius and AB is the tangent to the circle at the point of contact C. So, this angle, suppose this is angle 2. So, OC is perpendicular to AB, that is angle 2 will be 90 degree. Now angle 1 already it was given, it is perpendicular, so it was 90 degree. Now angle 1 is 90 degree, it was given. Why? Because PC was perpendicular to AB. If PC is perpendicular to AB, then angle 1 is 90 degree. And we got angle 2 also 90 degree. Now, angle 1 plus angle 2 will be, angle 2 is 90 degree, angle 1 is 90 degree. We got 90 degree plus 90 degree equals to 180 degree. If angle 1 plus angle 2 is 180 degree, then it is a straight angle. So, it is a straight angle. Straight angle. Straight angle means this will be a straight line, hence OCP, or we can write OP, or it is better you write hence O, point C and point P are lying on a straight line, point O, point C and point P, they are lying on a straight line. Straight line means PC will pass through the center O. Thus, PC passes through the center of the circle. PC passes through the center O of the circle. Hence, proved. Question number 6. The length of a tangent from a point A at a distance 5 cm from the center of the circle is 4 cm. That means the length of the tangent is 4 cm. Suppose this is the circle with center O and this is the tangent. Name is not given, give any name. Suppose it is the point A, point P. The length of the tangent is given how much? 4 cm. The length of a tangent from a point A, that means point A will be here. This will be point P. The length of tangent from point A at a distance 5 cm from the center. That means point A is at a distance of 5 cm from the center, and the length of tangent is given length of tangent is PA equals to 4 cm. Distance of point A from center O. Distance of A from the center O is OA equals to 5 centimeter. Find the radius of the circle. This is the radius of the circle. We have to find this. To find OP is how much? We know OP is the radius of the circle, and AP is the tangent at the point of contact, tangent to the circle at the point of contact P. OP is the radius of the circle, AP is the tangent to the circle at the point of contact P. Theorem 10.1, according to theorem 10.1, OP, therefore OP will be perpendicular to AP. That means angle P angle OPA is 90 degree, means OPA, it is a right triangle. Hence OAP is a right triangle. Now in a right triangle we can use Pythagoras theorem. In right triangle OAP, I'll kill this part. We have to find OP is how much. If it is 90 degree, OA is the hypotenuse, any one is perpendicular, another one is base. In right triangle OAP, you can write OP square plus AP square equals to OA square. OP, we do not know. We can write OP equals to root over OA square minus AP square. OA means 5 square minus AP means 4 square, 25 minus 16, square root 9, it will be 3 centimeter. So we got the answer. Find the radius of the circle. Therefore, the radius of the circle is 3 centimeter. Next question, number 7. Two concentric circles are of radii 5 cm and 3 cm. Find the length of the chord of the larger circle which touches the smaller circle. Suppose this is the larger circle, this is the smaller circle. Concentric means center is same for both the circles. It is a chord of the larger circle. Suppose it is AB, center is O. AB is the chord of the larger circle and AB is the tangent to the smaller circle. Suppose the point of contact is P. So at the point of contact P, AB is the tangent to the smaller circle and AB is the chord of the larger circle, and radii of these, suppose this is the radius of the smaller circle, it is given 3 centimeter, and suppose this is the radius of the larger circle, it is given 5 centimeter. We can join this. What to find? Find the length of the chord of the larger circle. That means we have to find AB equals to how much? Let us take this triangle. OP is the radius of the smaller circle and AB is the tangent to the smaller circle at the point of contact P. Theorem 10.1 we can apply. OP is the radius we can write for the smaller circle or for the circle with smaller radius. OP is the radius and AB is the tangent to this circle at the point of contact P. Then we can write OP is perpendicular to AB. OP is perpendicular to AB. That means this angle will be 90 degree. That is angle OPA is 90 degree. If it is 90 degree, then OAP will be a right angled triangle. That is, or we can write so, OAP, triangle OAP is right angled triangle. Since OP is perpendicular to AB, OPA, this angle is 90 degree, so OAP is a right angled triangle. Then we can use Pythagoras theorem. In right triangle OAP, this is how much? Radius of the smaller circle, it is 3 centimeter, and OA, it is the radius of the larger circle, it is 5 centimeter. OP is 3 centimeter. OA, it is 5 centimeter. This is hypotenuse, and any one is perpendicular, another one is base. That means out of OP and AP, any one is perpendicular, another one is base. But hypotenuse is OA. We can write AP square plus OP square equals to OA square. AP is unknown, so AP we can write under root OA square minus OP square, means under root OA means 5 square minus 3 square means 25 minus 9, it will be 16, that means 4 centimeter. We got AP is 4 centimeter. I have to clean this part. OP is perpendicular drawn from center bisects the chord. Now OP is perpendicular to AB for the larger circle. Also O is the center of this circle, larger circle. We are drawing perpendicular from the center O to the chord AB. AB is the chord of the larger circle. OP is perpendicular to AB, and the perpendicular drawn from the center bisects the chord. Forget the smaller circle right now. Suppose OP is the perpendicular to the chord AB for the larger circle. Then OP will bisect this chord AB. Bisect means AP length. This length will be equal to BP, this length. Hence, or therefore, you can write that is AP equals to BP. AP equals to BP. For what reason? Perpendicular drawn from the center bisects the chord. AP and BP same we got. AP result what we got here? We got 4 centimeter. So if AP is 4 centimeter and AP equals to BP, then BP also will be 4 centimeter. Therefore, AP equals to BP equals to 4 centimeter. Now, what is the total length of AB? Therefore, AB equals to AP plus BP. AP plus BP is total. AB equals to 4 plus 4 equals to 8 centimeter. Find the length of the cord. So we can write therefore the length of the cord is 8 centimeter. That means AB is the cord. The length of this cord is 8 centimeter. Question number 8. Diagram is given. ABCD. A quadrilateral ABCD is drawn to circumscribe a circle. Prove that. We have to prove AB plus CD equals to AD plus BC. This is a quadrilateral ABCD circumscribing a circle. A quadrilateral ABCD is drawn to circumscribe a circle. To prove AB plus CD. AB means this plus this. AB plus CD equals to AD plus BC. These are the points of contact. Suppose this is P, Q, R, S. AP is a tangent to this circle and AS is also the tangent to this circle. Then AP, length of AP will be equal to the length of AS. PB will be equal to PQ, CQ will be equal to CR, DR will be equal to DS. drawn from an external point to a circle are of equal length. This we studied in theorem 10.2. The lengths of tangents drawn from an external point to a circle are equal. Theorem 10.2 that we are applying here. Given data you can write ABCD is a quadrilateral which circumscribe a circle and it touches the circle at 4 points P, Q, R, S. You can write like quadrilateral ABCD circumscribes the circle and touches it at P, Q, R, S. After that you can write to prove it is suppose given to prove AB plus CD equals to AD plus BC. First you write this, then to prove, then it is proved. Tangents drawn from an external point to a circle are of equal length. That means we can write that is AP equals to AS equals to AS, PQ is equal to BQ, PQ equals to BQ, CQ equals to CR and DS equals to DR. Check once again. AP equals to AS. Here PB, it will be PB. PB equals to BQ. Then CQ equals to CR. Then DS equals to DR. That means this length are equal. This and this are equal. This one and this one, they are equal. These are equal. Next part, we have to prove AB plus CD. That means AB and CD we are writing first. AB plus CD. In place of AB plus CD, we can write AB means AP plus PB, AP plus PB. in place of AB we have written this one, and in place of CD we can write CR plus DR. Understood? AB means AP plus PB. CD means CR plus DR. We have to get the parts of AD and BC. What are the parts of AD? AS and DS. Let us open the brackets first. AP plus PB plus CR plus DR. We are trying to get AD plus BC. AD plus BC means D AP plus PB. In place of AP, we can write AS because AP equals to AS plus. In place of PB we can write BQ because PB equals to BQ. In place of CR we can write CQ because CR equals to CQ. In place of DR we can write DS equals to DR. Now AS and DS, we are taking this one and this one, AS plus DS, because AS plus DS means AD. BQ plus CQ, BQ plus CQ means it is BC. So AS plus DS, AS plus DS means we can write AD plus BQ plus CQ means we can write BC. So we have started from what? Where? AB plus CD. We have started from this part, AB plus CD. After that we got what? AD plus BC means AD plus BC. So AB plus CD, here we got AD plus BC, hence proved. Okay, today I have to stop now.